briefly when it's helpful, what it's helpful for, and then kind of how to use it. So the Pythagorean theorem, and I'm going to go ahead and present my screen and go from there. So the Pythagorean theorem has all to do with right triangles. So here's a right triangle. You know that it's a right triangle either because it's labeled with 90 degrees or it has the little square in the corner saying, hey, this right here is a right triangle. So I said this only works for right triangles. So if you have like an obtuse triangle, so if that's like 100 degrees, or you have an acute triangle where all of the angle measures are smaller than 90, okay, this fancy equation, so they call it the Pythagorean theorem, a squared plus b squared equals c squared. They don't work for these two types of triangles. The only other thing that I wanted to kind of reference before we practice using it is that I have these three letters in this equation, and the one side, the one of these letters that has to be in the right place in my equation is this C. So C has to be that angle that is across from my right angle. So if I change my triangle around and my right angle is over here, my C is going to be this side length right here. They call that the hypotenuse. So they call that the hypotenuse. A and B are interchangeable. So I could call this A and this B, or I could be like, oh, no, never mind. This is B and this is A, and it will work either way because remember, I can add in any order. 2 plus 5 is the same as 5 plus 2. So as far as knowing which one is A and which one is B, you can choose between these two sides. A and B are always the sides that make up that square on that right angle. So A and B are those, and they call those the legs. So A and B are the legs, and C is the hypotenuse. Now, to put this into practice, how do I use it? And the reason I use it is because sometimes I'm unable to physically measure. So let's suppose that I am putting up some sort of pole, maybe a flag pole, or actually, let's say a zip line. Okay, for today, we are creating a zip line. If I want my zip line to start at the top of this tree and end up down here on the ground, if I create a right angle, because that tree is going to be at a 90-degree angle from the ground. Now, I can't physically measure from the top of a tree all the way down here to the ground. It's physically impossible. So in order to determine how much rope or wire I need to create my zip line, we can use the Pythagorean theorem. So we can make our right triangle. Okay, we know our tree makes up one of our legs, the ground makes up another of our leg, and that zip line is going to make up my hypotenuse. So C is my hypotenuse, and if I know the tree is 60 feet tall, and I want my ending point to be 100 feet away from the base of the tree, so I don't go straight down and crash into my tree, okay, I can use the Pythagorean theorem to figure out how much I need to purchase to make my zip line. So to use that Pythagorean theorem, I would label my sides. This is A, this is B, or you can flip-flop them however you want. And C is my unknown, and I would plug my numbers into my equation. So my equation was A squared plus B squared equals C squared. So in place of A, I'm going to use 60. In place of B, I'm going to use 100. And in place of C, I'm going to not write anything in place of C because there is no number. I don't know what it is yet. So I'm going to square all of my numbers. So if I grab a calculator, okay, so here's my calculator, 60 squared see, 60 to the power of 2. Okay, and you can use that Desmos calculator, or you can use your calculator to do exponents. And I think this is probably an important thing for you guys to know. To do exponents, oh, there's a glare on the ceiling. You see this upside down V button. It's called the caret symbol. That's how I get an exponent. So if I wanted to do 60 to the power of 2, I would use that symbol. If you're using the Desmos calculator, let's grab the Desmos calculator. Not graphing, whoops, backwards. Math Tool Scientific Calculator. If you are linking to our home screen, if you want to do anything squared, I'm going to click 60 and then this squared button right here, and it's going to square my value. So I get 3,600. So let's go ahead and calculate this. So 3,600, 100 squared, if I use my calculator, is to the second power 10,000. Okay, so I have my 10,000 equals c squared. Don't forget to add that plus sign. Now I'm going to add those two numbers together. So 3,600 plus 10,000 is 13,600 is equal to c squared. C squared. And to undo a square, I'm going to take the square root. I'm going to take the square root. Now on a scientific calculator, let me go grab one really fast. On scientific calculators, so for example, if you've got one like this, to take the square root, you'll notice above this x squared button, the squared button, there's a square root sign in like this purplish color. And you'll notice the second key button up here is that same purplish color. So I would hit the second button and the x squared button and then type in my number, 13,600, click equals, and that's going to tell me how long that c side is. So c is equal to, what? Go back. Let's see. I'll just do that again. 116 point. Now, if it asks me to round to the nearest tenth, remember that's one decimal place. So I would do 116.6. But if it asks for the hundredth, that's 2. A lot of the times people think that I'm just going to write 6-1 and leave off the rest. But remember, to round, you have to look at that one number after. That 9 says that 1 is closer to a 2. So if you round to the tenths place or one decimal place, I've got 116.6. Or if I round to the hundredths place, I've got 116.62. On the Desmos calculator, your square root button is just right here. So the square root of 13,600, and you can see I get that value right there. Any questions that you guys have so far? Okay, so I see you shaking your heads no. There's one thing that I want to point out. Sometimes I have students say to me, Ms. Johnson, it would just be so much easier if I just added 60 and 100 first, so I didn't end up with these huge numbers, and then square it. So what they're telling me is they would do 60 plus 100 and then take that number and square it. But what I want you to notice is 25,600 is very different than 13,600. Okay. So make sure you follow your order of operations and square both of these numbers, simplify them before you add them together. And that's just one thing that I found that I just want you to kind of be on the lookout for. The last thing that I want to talk about is how to find the unknown side. So for example, if my unknown side is A, and my length right here is, let's say it's 120, and this length right here is 300, let's say. I'm just making these things up. But let's say I knew how much rope I had to make my zip line, and I knew how far I wanted the base of my zip line to be away from my tree. So here's my tree. Okay, if I wanted to figure out where I wanted to put my platform for my zip line in my tree, so we're assuming maybe it's at the top of the tree on my picture, I'm going to still use the Pythagorean theorem because maybe I don't want to physically stretch this out. I don't know how long I need to make it. So I'm going to use the Pythagorean theorem, but I'm going to use it backwards. Because I don't know A, I'm going to make it A squared. I'm going to label my other two sides. This is B because it's my other side that makes up my right angle. I know this is C because it's across from my right angle. And now we'll fill that in. So A squared, 120 squared equals C squared, which is 300. So sorry, scratch that C, right in the 300 squared. And then we're going to simplify. Remember to square everything first. So to simplify these exponents, 120 squared, and we can do that on this calculator, 120 squared is 14,400. And these are large numbers, I know, but we can, let's see, 14,400. 300 squared is 90,000. Don't forget to bring your equal sign down in between those two numbers. Okay, they're going to stay on opposite sides. Bring down your plus sign, bring down your A squared. And then we're going to solve this equation. So it's been a second since we've solved equations, but remember equations, I've got that line down my equal sign, separating out those two sides. And I'm going to isolate my variable. So get rid of whatever's furthest away first. So 90,000 is on the opposite side, so we're going to leave that over here. But 14,400 is the next furthest thing. And it's being added, so we're going to do the inverse operation. So we're going to subtract 400. So in my calculator, 90,000 minus 14,400 is equal to 76,000. So A squared is equal to 75,600. And my last step is going to be to take the square root because I want to do the exponent. Okay, and undoing the exponent of squared is to take the square root. You'll notice they both have the word square in them. So that's kind of how I know they go together. So I take my calculator. Now, this is a different type of calculator. You might have this one. Square roots on this calculator or just this button. Square root of 75,600. And I know my tree, where I want to put my platform in the tree is 274 point. Now, if I want to round it to one decimal place, that 5 is going to kick that up to 10, which is going to kick that 4 up to a 5.0. If I want to round it to two decimal places, I have 274 point. I want to keep the 9, 5, and then I'm going to look at that 4 to see if that 5 needs to elevate. And it's a 4, which is less than 5, so it's going to stay the same. So when I want to know this unknown side, okay, remember, and this unknown side meaning one of my legs, not my hypotenuse, okay, I have to put everything into my equation, square everything, and then instead of just adding my numbers together, I end up subtracting before I take the square root. All right. Any question? Oh, I'm going to get rid of this. Any questions that you guys have? Any questions from past assignments that you guys had? Okay. Now, if you are still not logged into Alex, or you can't get logged into Alex, you don't know what your password is, or hey, you're having issues with that, please let me know so that I can get you logged in and going. Other than that, I want to give you guys time to maybe go ahead and watch. There's a video on the Pythagorean theorem for tomorrow, and like a short little questionnaire about it. If you want to do that right now, that would get you ahead of the game for tomorrow. So, all right, if you guys have no questions, I'm going to say See you later. If you do have a question, stick around for a second and I can answer those. Have a good day. Have a good night.